If you've ever played with magnets, you'll probably notice that when like poles of the magnets are facing each other, so two norths or two souths, the magnets will repel, but hold two unlike poles together, they will attract. Magic. Well, not really. And here's why. All magnets have something called a magnetic field. Magnetic fields are invisible and surround the magnet, causing a magnetic force. This is what causes magnet materials and magnets to either attract or repel. Magnetic fields always follow a few basic rules. Even though magnetic field lines all have the same strength, the strength of the magnetic field is greater the nearer to the magnet. Can you guess why this is? It's because the field lines are more concentrated, increasing the overall strength of the magnetic field. If you think of a magnet, you don't see lines coming out of the poles. Magnetic field lines are invisible, but there are two things we can do to show the field lines. Iron filings can show us the shape of the magnetic field, which we show as a simplified diagram like this. So iron filings show us the pattern, but they don't show us the direction, which is where compasses become useful. So how can compasses show us the direction? Place some small compasses around a magnet. The arrows of the compass will move so that they are pointing towards the direction of the magnetic field. Then, using a pencil, draw a dot where each arrow points and then connect the dots. The compasses will show the direction of the field lines going from the North Pole to the South Pole. Simple. We now know the direction of the magnetic fields. We will look at compasses and the Earth in another video. There are two different types of magnets, permanent and induced. Permanent magnets are always magnetic, meaning that their magnetism can't be turned off, whereas induced magnets aren't always magnets, they are unmagnetized most of the time. But when placed inside another magnet's magnetic field, it acts like a magnet and attracts. Magnetic materials like iron and steel can be turned into magnets. If you place an iron paperclip close to a permanent magnet, but without touching, the paperclip will become an induced magnet, with the end nearest the magnet having the opposite polarity of that of the magnet. Because the paperclip is now an induced magnet, we can add another paperclip to it, and another paperclip. This is of course a temporary process. Remove the nail of the magnet and the nail will lose its magnetism. So in this video, you learned about the north and south poles in magnets, attraction and repulsion of magnets, magnetic fields, and the difference between permanent and induced magnets.